The first thing we want to look at here is some basic things concerning images and colors and what are traditionally called the modes, the different modes of Photoshop images. And it's very important what mode you're in, and as well as file formats. And first thing we're going to do is I've opened up the Dune image, and is always a good one to look at. And the first thing we want to do is I'm going to change the mode, and I want to get to a 1-bit image, a pure black and white image. It's the bitmap mode, but it's not, as you can see, it's grayed out. So we have to convert first to grayscale. And I'm going to discard the color information, and now go back up, and here I can access bitmap. Okay, bitmap is the most basic form of a graphic. All of the pixels are pure black and white. There's no attempt to make it look realistic or like continuous tone. And when we start to zoom in, we in fact see that every pixel is either black or white. There's no gray or attempt to make it look like we have gray tones, and certainly not any color. This we want to look at the modes. Also involves looking at the channels. And the channels are the sort of background component pieces of an image. And just so that we see what's going on, when we're in a bitmap mode, there is one channel. The component pieces, parts, I don't want to say layers, because we use layers to separate the elements in our files when we're working on them. But the under the hood component of Photoshop images is the channel, and it contains the basic color information, or black and white. So in this case, we see that there's no attempt to create the illusion of grayscale or continuous tone. Pixels are pure black and white. All right, I'm going to revert this image back. Okay, and then I'm going to go now to the next mode. The next mode is, in fact, grayscale. And here, when we look at the image, we appear to see something that looks like a traditional black and white photograph. There appears to be dark tones and light tones and subtle transitions between those colors, which we refer to as continuous tone. But in fact, when we zoom in, we realize that it's smoke and mirrors. It's all an illusion. That in fact, this is made up of a series of little square pixels. And the square pixels appear to have varying shades of gray. But we know that that is also an illusion. If we could take any of these pixels and zoom in even further, we would in fact see that each pixel is broken down into a smaller grid of little black and white pieces. And the more 16 by 16 grid, or a total of 256 shades of gray, illusion of little mini boxes of black or white. And the more little pieces of that 16 by 16 grid that are filled in with black, then our eye mixes it all together, and it gives us the illusion of a darker tone. If more of them are left white, then the illusion is that we get a lighter tone. And 16 by 16 means that we get a total in grayscale of 256, which includes one black and one white. So 254 shades of gray, plus black, plus white. And when we look at the channels, once again, what we see is there's a single grayscale channel. It's 2 to the 8th power. It's called an 8-bit graphic, one grayscale. Okay. Then I'm going to go ahead and I'm going to convert back to color. And when we convert to color, we have two different kinds of color. We have, in this case, the mode is RGB, red, green, and blue. This is electronic color, and this color exists in our electronic devices. The light source is what lights up, directly lights up these pixels and these little electronic elements in our monitors and TVs, and this is what gives us RGB, or red, green, and blue electronic color. And it's very intense, it's very rich. We can create colors here that cannot be recreated faithfully in our environment, or environmental color, or real world color if you want to call it, in CMYK, as we can, we're limited in the colors we can create if you have paint, regular paint, or ink on a printing press. You can't create a lot of the colors that are available in RGB. And here's what I'm talking about. I'm going to go and create a very rich, intense, almost electronic green. And if I, in fact, fill this object with the screen, as you can see, it's very rich and it's very intense. And when we convert this color to standard printing press ink or regular paint, you wouldn't be able to create some of the colors that you can in RGB when we convert to CMYK. And because it's just more limited, because the physics of how the color is created is from an external light source that reflects off the surface. So you see, this is very rich and very saturated. And when I convert it to something that approximates color in our environment, look at how much more dull it quickly became. You can see the difference very easily when we do that. There's RGB color. There's the same color when it's converted to approximate what it would look like printed on a piece of paper. Much more dull, okay? And in RGB, what we see are three channels. We see what's called the composite channel, all the colors combined, and then we see the individual channels. And these are, when we start turning off the eyeballs, what we actually see is that this image is made up of three of those 8-bit grayscale images. And when we add color to it, to see it on the screen, or we add color information that comes out in our printing device, this is like a black and white version of the color information. And when we have more than one turned on, we see the colors combined. But if we have them all but one at a time turned off, you see that they're just a black and white version of that color information, like looking at the image on a black and white TV, if you would. Okay. Then what we typically do for printing, we need to convert this to CMYK. Now, notice before we even go any further that in CMYK we now have 4 of these channels, each with a different piece of color and the composite channel. And once again, when we turn off all but one at a time, we see it as a grayscale image. It looks just like when we had a black and white photograph. When we zoom in, there again we see that the pixels appear to have different shades of gray, but we know that that's an illusion, and there's no color in the computer until the image is sent to your printing device. And but in CMYK, when you have several of these turned on, this we're familiar with. Blue and red is going to give us purples. Blue and yellow gives us shades of green. And this is the CMYK color mode for channels so that each color can come out on a separate piece of film in the printing process. And this is how we do things. We generally work in RGB so that all the filters and things work, and the files are 3 channels, so they're smaller. And then when we are getting ready to put our images into documents for high resolution output and printing, we want to make a copy of them in CMYK, and generally we flatten them and then save them as TIFF files, and those are then prepped and ready to go into our individual documents.